As Alan mentioned, I do run our next generation test automation agenda globally for Accenture. Do a few other exciting things for clients in between. But today, that's what we want to kind of bring this to a start for you with. And then Paul?
And I'm a senior principal in Accenture's testing practice, the same group Hans is in. And my focus is largely tools and, well, processes, tools, and automation in general. Shall we begin?
Yep, let's kick it off. Okay, so we're going to start you with a really quick video just to intro some of our perspective around AI.
What if it could put an end to all the mouse clicks and keystrokes and make room for people to create? What if it could close the pay gap between genders by turning bias into equality? What if it could help the blind achieve more by using sound to give them sight? What if it could help cruise ships become more clairvoyant and car makers be more collaborative? What if a single collaboration between humans, birds, and AI could lead to conservation? What's the power of AI? It's infinite. But it has no perspective of its own, no point of view, no purpose, until people put it in motion, turning imagination into reality. Accenture. New. Applied now.
All right, so with that set as context, I just want to talk to you a little bit about why we think this is important in relation to automation, in relation to quality and the quality imperative. First of all, from a traditional perspective, it was always important to have the right level of focus, but narrowing focus is going to be more important than ever, and we'll talk a little bit about why that is later in the presentation. Secondly, yes, AI gives us the huge potential from a productivity, from a breakthrough, from what can actually occur. But how are we going to actually bring that to bear in a way that allows us to mature that in an intelligent, thoughtful way? And we have a lot of reason to believe that we in the marketplace are a little bit behind there. And then finally, to really kind of bring this full circle around the testing and automation theme that we've been focused on for the last day and a half, what happens if that AI doesn't bring to bear the values that our organizations propagate, put forward, and actually stand up their entire business foundation and themes upon? So we'll explore that in this presentation.
All right, where we're going to kick off from is research that Accenture does every year. We do something called the Technology Vision. We produce it usually in the first month of the year, sometimes early in February. And this is the result of research that our research department does each year throughout the year. And basically what they do is they research the technology trends that they see emerging, and they develop a set of surveys. And this year's the 2018 Technology Vision, there were about 6,300 executives from around the world, 55 different countries, I think, who were interviewed and gave us their perspective based on these trends we're seeing, where they see those that will impact them and their businesses, and also where they intend to make their investments. And we come out every year with these 5 broad trends. We're not going to deep dive into this other than to highlight that the leading trend is, in fact, around AI. And we'll show you how the trends evolve a little bit, because AI has been a dominant trend now for several years. And that's why it's important that we figure out how we as testers and as quality engineers are going to be able to deal with AI-based systems. You'll see the range of things here. As I said, I'm not going to go into these various trends, but it is useful to think about that. What we're looking at is we're projecting what we see will happen over the next 3 years, so that customers can, in fact, start to look at how do they need to modify the way they do business, the way they build systems, the way they run their technology to take advantage of these trends, or not to be forced out of the market by the trends, as some of them are quite disruptive. I mean, there's some big, bold predictions that come with this. For example, around AI, the prediction is that by 2025, a nation or a subnation, a province or a state, will ban human-driven cars. They'll force you, if you're driving on public roads, to have auto-driving cars. AI is getting to be so good at being creative that we have a prediction that somewhere between 2025 and 2028, AI will produce a global blockbuster film, entirely produced by it. It'll write the script, it'll cast the virtual characters, it'll do the scenery, it'll direct, produce, and distribute. Things even go further to with things like extended reality. By perhaps 2025, it'll be possible to have a visual implant on your eye that will essentially give you extended reality, virtual reality, without a headset. And by 2030, we're expecting, for example, some nation will probably make that the way education is delivered. I'm not going to go into more than that.
Sure. Well, let me try to put it in perspective too. Because as we go through this process from year to year, we find that oftentimes these predictions and these trends not only turn out to be reality, but if we head on a little bit here, they often have a natural building block process and a foundational element of journey towards them. In this particular case, as Paul highlighted Citizen AI from 2018, if we look back to 2016 in the trend one of intelligent automation, we had a belief and we built a program and a set of agenda topics and strategies around that. And generating that foundation of intelligent automation for us was very key towards the quality engineering transformation. We referenced that off earlier to this morning in Jeff's discussion. Building upon that, we actually built a strategic partnership with a number of vendors to be able to bring intelligent automation to life in an industrialized, repeatable way that would give us that QE pivot foundation opportunity. The strategic Tricentis partnership was an excellent example of that. Taking that on to 2017, we built upon that foundational success that we were pleased with. We continued to scale it, but we looked how we could bring that AI as the new UI theme alive with what we're doing with our touchless testing platform. So many of you downstairs at the booth may have had an opportunity to meet with Sean Gorman and team and look at what we're doing in the touchless testing space. But AI is really the power of the platform in terms of where it's going on a trajectory basis. And as we head into 2018, today we'll take you through a little bit of how we can bring this theme to life and make it real for you.
And you can see in 2017, AI as the new I was one of the trends. Now these are cross-industry. It's not intended to be aligned with any industry vertical group. So these are the trends we're seeing that we believe will impact businesses going forward for the next 3 years or so. So the interesting one for us from here is AI as the new UI. So how are we going to test this? Let's move forward. The way we test is by what we call applying intelligence. You want to pick up?
Sure. And so from a test optimization standpoint, we've spent a lot of time in the past talking about what we test and why that matters and how we have to be very strategic about what we test. Over the course of time, people have been very thoughtful about how to bring risk-based testing to the table in a way that actually was strategically a breakthrough. There have been a lot of kicks and sputters and false starts with that. There are a number of solutions that really enable that. But one of the impediments to being able to thoughtfully move forward with risk-based testing was, a better set of a lay on the ground, a better set of analytics to drive. And Paul, take us through a little bit about why that's now actually on the cusp of some reality.
So underlying some of these statements we've got here is these are the core things we think we need to focus on, is some analytics we conducted across many of our client engagements and our projects. So for example, one of the things we find, and I think this will resonate with most of you, and it harks back to something Wolfgang said this morning around risk. Where does risk lie? We typically find that 80% of the risk lies in 30% of the application scope or functionality. Yet on the other hand, our analysis also tells us, and this goes back many years now, that 40% of all the tests we build have never found a defect. But we run those tests, right? Because we are afraid of what might happen if we don't find that. When we look at things like defects, for example, we often find that if we look at the defects, our analysis shows us that 25% of the defects, only 25% of the defects, have anything to do with the UI. About 20 to 25% of the defects are associated with environments and data. Generally, we find that any single root cause may generate as many as 20 different defects. If we look at optimizing tests, we had this instance recently where we used a particular tool that does similarity analytics, and we analyzed the test suite one of our energy clients had for their ERP system. That was SAP. I think they had 4,500 end-to-end scenarios, fairly big business process scenarios. And we found that when we did this analysis with similarity analytics, which compares the tests, every word, every attribute of the tests, and looks for commonality, we found that 18% of the tests in that 4,500 tests were cut and paste clones. Somebody had cut out a set of tests somewhere in ALM or wherever their test management tools and pasted it somewhere into the hierarchy, and they ran those. Look, we then found that there was a lot of commonality in other tests, but you expect that if you modularize your tests appropriately, as you would with a tool like Tricentis, you're going to build things once and reuse them many times. But in this case, this had originally all been built manually.
So when I first saw this slide, I knew we wanted to spend at least 45 minutes on it, but instead we budgeted about a minute. So let me just leave us with, the world is going to change as we bring applied intelligence into the entire process that we now know and love. And so to actually take that forward just a little bit, I'm going to hit the next slide.
We're going to focus on two things with AI and testing. The one is, how do we use AI as an enabler for testing? And the second thing is, how are we going to test AI in the future? Systems based on AI, leveraging some form of AI. Look, we know there's many aspects to AI, but we'll look at something fairly basic, one of the foundation things we see. By the way, what you're seeing here is a pyramid of dimensions or functionality in AI that increase the complexity of the testing, and we'll come back to that in a moment. Just to start off with, from an efficiency perspective, we look at 4 primary areas today, and these probably aren't the only ones. It's the ones we happen to have focused on. So if we look at how can we leverage elements of AI to increase automation? Well, one of the ways we're looking at doing is how do we use computer vision? Now, the way a manual tester interacts with an application is based on their visual perception of what they're seeing as they go through the application. This is one of the reasons why exploratory testing is so effective as a complement or supplement rather to automated testing, is that variation in response. How could we perhaps take automation and make it much more like the way a human does, a way a human perceives things? Unfortunately, automation today needs some knowledge of the implementation to be able to work. It's got to know how to recognize objects, what sort of attributes and states they may have. If we look at predictive analytics, can we look at past test results, past programs we've operated, and see what it tells us about the future? Can it help us predict quality levels, failure rates? Can it help us optimize where we might want to test, where we've seen that? Prescriptive, that's a little bit more looking at things like, as I said earlier, how do we optimize the tests based on perhaps change impact, or on where we have seen effect. There was in the previous slide, there was something called test vitality metrics. One of the things we found vastly beneficial is to measure the use of a test case over time and how many times it's actually found a defect. And as I said, we often see that we run these tests again and again, and they never find a defect. Perhaps we should focus on those tests that actually find defects. And the last thing is augmentation, and that's augmenting the human tester with virtual assistants, with their own bots, their set of bots, that they can command to do some of the grunt work that would normally be involved with testing.
Sure. Thanks, Paul. So one of the things we want to do is be hugely repetitive today and bore you to death, but at least we can maybe get a couple quick takeaways. One thing and one theme that I want to make sure we leave with today is that we'll deal with fundamental change as we deal with bringing AI into the focal point and being able to test thoughtfully what's happening in that space. So I wanted to go ahead and use chatbots as an early illustrative example. Chatbots from a proliferation standpoint are growing almost exponentially. I was going to join in with the math analogies from earlier, but I didn't find the right one. Parabolic wasn't it either. But the growth trajectory in chatbots is nearly infinite. Testing for that is going to be a very significant challenge. So we want to talk a little bit about that.
Sure. So let's start out by what normal testing today is. If we look at today's systems, I mean, testing is deterministic. Usually the systems have a set of rules, a defined set of, a bounded set of inputs, and we can determine a fixed set of outputs for any set of inputs. Obviously, the sex in testing is figuring out the right combinatorial design so we optimize and get the smallest test set possible. We don't want to test every permutation, but literally we know what we should get as an output for a given set of inputs. It's not that way with AI. With AI, you don't have the same structured set of inputs. A lot of the feeds into AI are unstructured. And by that I mean they don't fit into fields, variables, or parameters for either an input of some form, whether it's a UI or a set of APIs. The data is largely unstructured. It may be text. It may be a voice input through a voice recognition. And as the AI modifies and learns from the data and updates its own internal algorithms, obviously the set of outputs can vary and can vary over time. This makes life particularly complicated as a tester because how do you know that the answer is right? Does it look reasonable? Does it match things you've seen in the past? That's one of the things that we have to figure out how to do this. So this is where we're going to be focusing in terms of using AI. Now we look at AI having several different dimensions. And if you remember when we went into the mobile space, and all of a sudden we had a proliferation of devices and the different versions of the devices and the different versions of the browsers on the devices, it made testing complicated. We had a bunch of different configurations. With AI, we've got these various dimensions that we have to focus on. Functional AI, that is, does it give us the right thing? Then the logical, can it reason? Can it adapt? Can it learn? And we'll just for fun, we're going to go through just a quick, simple set of things. Again, the concept of ethical AI. Can we prevent AI from doing bad things? Because remember, AI is it learns from the data it's given. If that data is bad or unethical, it will behave unethically. You saw that the trend that we had in 2018 is responsible AI or citizen AI. We have to raise AI like we'd raise children to be good. So just to give you a quick example here, it's a silly little example, but this is an example of functional AI. You can query the AI and ask it, what time does my flight leave? Now, you didn't even have to give it the flight number because it has access to your calendar. It can go and look it up, but it can go to a schedule and there's an answer. Now, it may get a little bit more complicated when you say, well, when do I leave home? Now the AI has to integrate or interface to other systems to look at traffic patterns, routes. If it's an international flight, you've got to get there earlier. Learning AI, you ask the AI to give you a playbook, a playlist for the flight. It's got to go back and look at your music, the history of use, and come up with a playlist, what your likes and dislikes are. Of course, you don't want to have this. I mean, the AI can go out and look up the Airbus manuals on the internet and probably figure out how to crash the plane, but that's a behavior you want to prevent. And that's what part of the testing will be. And then finally, you expect the AI to behave in a sympathetic manner to humans so that they have a pleasant experience with the AI. It's one of the reasons why people want to use chatbots over human people. Sometimes when they call up, we find an increasing number of people, especially around the millennials, prefer to actually use chatbots than to speak to human agents.
I don't really fit into that paradigm. I prefer to talk to humans. But right. Increasingly, that's not the paradigm we face, and we need to be ready and responsible for both scenarios. So yes, we gave you an exaggerative example, but it takes you through the lens of each of the key components that we'll need to think thoughtfully about and apply our abstract planning for the right level of testing.
So we're going to talk a little bit about how do we test it. This is a typical traditional software testing model. As we move into AI, we've broken this down into a slightly different pattern, and we have two aspects to this. Because what is it we're doing when we test AI? Well, we need to make sure that it responds as it's expected to, but based on what? It's based on the data and the way it's learnt and modified that data over time. So we look at this as a two-phase process. One is we teach the AI, and then the next is we test that it used that data correctly and those algorithms work. So we call it teach and test. And literally what we're essentially doing is extracting data, whether it's from production or we're curating the data. In other words, something like a sort of an action response pair, and feed it to the AI, run it through various algorithms, and essentially, so it's no different from a golden data set, really, right? Where you've got a set of data that you know that gives you a sort of set of responses. Now, the AI is not going to work the way a typical business rule system will do, because it'll adapt over time, and it'll depend on the amount of data you give it over time. But the idea here is you give it a curated set of data, and you train the model. And then when the model is being used, the AI is being run, you monitor it looking for outliers, things that are abnormal, that don't fit the patterns. And that's where you have to have this continuous monitoring evaluation. So that's the basic set of approach to this.
Sure, and to put this back into context, no different than in 2016, we built our intelligent automation and next generation test automation agendas from a nascent small starting point to a more robust industrialized program today. And we built a touchless testing platform from its original inception to where it's at today, if you saw that downstairs earlier. This is the start of our next big foundational initiative to drive off of the theme.
Right. So we'll just take a look at this. So we basically wrap this up into a framework. Literally, there's guidance and a methodology around doing this. And then there's a link to a bunch of tools to do the monitoring and the evaluation of the outputs. And all of this is based in the cloud so that it can be used almost anywhere. So it's basically a concept and an approach. Now, it's not cookie cutter by any manner of means, because no AI is. It's always adaptive, and it always depends on the domain and the data you give it. One of the challenges we have is the way AI uses the data sometimes produces unexpected results. It draws conclusions that are clearly wrong, even to the point that those of you who have seen some of the films around Watson and some of the answers it gave, for example, playing Jeopardy, that were just flat wrong. And that's because That's the inference it drew from its data. Now, that can be adapted over time. That would be an outlier, for example. Like, there was one example I remember was it asked about an airport, and it should have answered, a US airport should have answered Chicago O'Hare, and it said Toronto. It was totally wrong. It wasn't a US airport at all. How did it get there? Well, somewhere along the line, there was an outlier or something wrong with that data. So part of this is an approach to getting there, to getting an AI model that is producing the right things and then making sure you can validate that and continue. Look, why do you have to validate that it's doing the right thing? Because somewhere along the line, this is going to be a compliance issue. We spoke earlier about responsible AI, citizen AI, ethical AI. One of the biggest challenges with AI, think about AI that is doing, for example, health claims adjudication. And we all know that the way those systems work today, sometimes it's not fair, it's not rational. But if you have AI, and frankly, when you look at machine learning, after a while, there is no way to know how to reach decisions. But that's just not going to work in an industry like life sciences and healthcare. You're going to have to justify why you turned down a claim that was turned down by AI. And to be able to do that, you have to have a method that will let you say this is how the decision was taken. And that's literally the concept behind teach and test is how do we validate that for a given set of data, it will produce the response we expect. Now, the response we expect, how do we get to that? Well, sometimes it's through doing this massive, in a parallel form with different AI models. Sometimes this can be based on historical production. You use production as the oracle for the fact that you're going to use AI in place of humans or business rules-driven systems in the future. There's a case study here that we can go through very quickly, except you probably can't read the writing. We did this for a financial institution who wanted to put a chatbot in place to interact with their customers, to expand their typical channels of email and mail and all the things banks do. And they wanted to have the ability for customers to call in, and then the AI would go through a question and response and try and get them to where they needed to be in terms of speaking to either a human agent or signing them up for a product or a service. And so really what we did is this concept of supervised learning. Curated data based on data we got from the client. We had to go through something called debiasing. One of the things that happens in data all the time, and I think there's an example here, is with this raw data that we ingested, the data has inherent bias in it. What this particular data shows, you want to
Sure. So it's a really simple example, but it's a really powerful one. So at the bottom, we see sort of a level of acceptability. At the top, we see a level of bias that's going to be unacceptable both socially and in practice within the organization. This is a gender balance analysis. And in this particular case, you see male gender orientation and female gender orientation, female on the left, male on the right. And then we see sort of the acceptability of the usage of terminology in the course of conversation. We can quickly get to, and as you dot plot, some of the patterns that are in place that would need corrective and remediative action. Right. So while this is a very reactive screen example in this particular case, it's a really perfect example to bring alive what we're really trying to solve for from a quality perspective. We talked a little bit earlier about how the world of quality would look different and the nature of what resources do and what in the world are we going to do with those 40,000 manual testers. As we reshape the workforce, some of the skill base is going to be very oriented towards trying to have a business lens around it.
One of the things we do here, and you'll see it, is called 70-30 training scoring. What that means is the data that they gave us, so we could train the AI, we use 70% of the data to train the AI, and we retained the other 30% as a control group once the AI went live. And we then would use that 30% as a control group for the AI. To see what's happening. And then, as you said, we could find these outliers, and then we create these scatter plots, and the pink dots indicate where the AI was taking the right decision. The blue ones where ultimately it was determined that they were invalid decisions. The way this bot was set up is when it made one of those decisions that was one of the blue dots is hard to explain or hard to see here, it would get the AI, in other words, when it got it created an outcome that was perceived to be inaccurate, at that point the AI would forward to a human agent. A human agent would then make the appropriate decision, which would feed back into the AI, so the AI learned from that going forward. So this is an example of how we've implemented this over time, and you'll see strange terms like metamorphic testing that somebody came up with. All right. Just the implications for testing. How are we going to test this, and specifically how are we going to automate this? Well, it is going to have some challenges, and what we're going to present here is just a high-level framework in the interest of time, because I don't know what the time is.
Well, we're
Yeah,
standing
time.
between the group and the announcement of
Right.
the passport prizes, so
Right.
I
And
think
drinks.
they want us to
And
go
drinks.
quickly. Right? And drinks.
So we
yes.
got there. So particular example is, what we recommend is you build this AI reference architecture. And we'll come into that in a little bit. But part of this, you need to be aligned with the industry. Now, earlier, Volker spoke about two of the dominant players in the AI space. And by the way, we completely agree with him that you're not going to test the AI itself. The AI is going to be a service. But you have to test the results that the AI produces, because that is what drives your business. And that's what you're going to have to justify to your consumers, your customers, and your shareholders, any decisions that makes. So there are 5 dominant players in this space. He mentioned Amazon and Microsoft. And Microsoft probably has the biggest set of APIs. And this, by the way, it is all API driven. Microsoft has 24, 25 major APIs in the space. But the other big people are Google, IBM, of course, and Salesforce are coming along with something called with AI called Einstein.
Just
And
like the tower, right? Just coming
yeah,
along.
it's coming along.
Yeah.
And I can't remember the 5th. I'll remember it in a moment. Old age. So basically, I want to establish this reference architecture, and it's going to be linked to those industry partners. Now, the industry partners you establish are not only going to be with the AI providers, but also with specialists in this space, data scientists. The number one job that people seem to be after today is hiring people is data science, if they're anywhere in this space, or just in general, the scope of BI. What does it take to be a data scientist? If you do comparison shopping, you're a data scientist. Anyway, the other thing is in this layered sort of architecture, you need to create hooks into these different blocks. You want to break this down. You want to treat the AI as one monolithic thing, because you have this what we call combinatorial explosion. There's just too many things to test. But if you can layer it, like I'm going to test the functional aspects of the AI. I'm going to test how does it reason or apply logic. Does it learn when I give it new data? Look at those as separate layers that you need to build hooks into. You need to be able to see the states, and you also need to be able to drive them at that level. And then finally, as I said, simply build methods within each of these architectural blocks. Now once you've got this decomposed like this, now you can see how you can apply automation. Okay? Because it's not that different from anything else. Hans mentioned this earlier. This is not necessarily a new problem. The problem is really, how do we create the oracles? It's that fact that it's not deterministic anymore. We don't know up front what the answer is going to be. So we can't say, I give you this, did you give me that? Okay, a little harder. Okay.
So yeah, thanks, Paul. A couple things. Some key takeaways. Other than from a sartorial expression standpoint, I don't have the Wolfgang Platz look going on. But we covered off several things, but I do want to have an opportunity to have remembrance and a good takeaway on a couple of key points. One, unleashing optimized targeting. We talked earlier or Wolfgang talked earlier about some of the exponential complexity added in the load testing space by the propagation of mobile testing, as an example. In our presentation, I hope you take away that the exponential expansion of complexity in testing from the AI perspective is going to bring a fresh set of challenges. So unleashing optimized targeting is going to be critical. And there are a number of things that we've talked about that should be able to enable that and will be able to enable that. But our level of focus on that in the past has been insufficient for the nature of the challenge standing in front of us. Second.
Oh, I probably do it. You weren't done with that? I was thinking of the bar. I mean.
I was as well. That's why I ran the 2 points together. Okay. I was trying to speed that bit up. As Paul kind of rightly took us through, the world of defect uncoverage is now insufficient. From a mobility perspective, we're going to get a heck of a lot smarter at how we test for design elegance and appropriateness across a solution and an experience. In the context of AI, responsible use, so we can actually unleash the innovation and growth for positive reasons, which is its intention, as opposed to things that would create giant shareholder scandals and customer service scandals are certainly at the forefront. And so what we want you to take away in this particular case is this is probably the piece the market is overlooking the most in our perspective, and we're thinking from an early adoption standpoint precisely how we solve it.
Any questions at this time?
Are there any concrete examples of usage of artificial intelligence
Commercially available.
So from a commercial perspective, I'm not aware of anything at a robust scale that would speak to that.
Yeah. So we're using it in our touchless testing platform to do, we call them smart apps. We call them bots, but they're smart apps. There are things, for example, that will do analytics. So to give you an example, one of the things that slows down agile projects is the amount of time it takes to go through a triage. However, if a defect gets logged, and instead of waiting for a triage process or somebody to look at it and do an assignment, if a bot can go in there, scan that defect, compare it to every other defect, figure out who fixed the similar defect, the best person, auto-assign it there, that's a form of smart app. So we have that sort of thing built in. We're using commercial tools for that. We're not a tools company. We don't build tools. We use them. And so in our case, we're using something called Saffron Technology. It's an Intel company and it has this wonderful analytics engine for similarity analytics. Similarly for that, in that same case, for the defect analytics, we can have the analytics running as a live engine, and as states change for defects, for example, a developer fixes the defect. Instead of waiting for somebody to get an email to say this defect's fixed, go run your test, the AI says it's been fixed, who logged it, did they have an automated test? Oh, let me go run the test. Now it's got to get a bit smarter than that, because it has to be tied into your DevOps pipeline. The code has to be staged, pushed, deployed, tested, and then the test can be rerun. But that's the type of thing where you can use off-the-shelf AI to literally do that type of analytics.
And that said, there's nothing you can go commercially buy that's going to give you the silver bullet today that we're aware of.
Yeah.